All right, so this is a presentation for BQS514 research methodology, and today we will move on to regression and correlation analysis. Um, this is a bit of an introduction to the topic, so any part which is like a bit detailed, okay, I will just skip through. Okay, all right, so as we have discussed before, in doing research, you have to identify your variables and you have to identify which one is the independent variable, which one is the dependent variable. Okay, and when we are dealing with two or more variables, there would be a relationship between those variables. So this relationship enables for us to do analysis upon it. And if we elongate that analysis, we can even do future predictions of that particular relationship. Okay, so um, so how to make these forecasts? Okay, so they are based on the current relationship values, then it is already known, just that we estimate it for future events. So in order for us to come out with this type of forecasts, we need to establish the relationship between the variables. So regression and correlation analysis, they are based on relationship between two or more variables. So we are talking about bivariate or multivariate analysis here. Okay, so a bit of recap here. Okay, we have the independent variable, which is known, and then the dependent variable, which is the unknown or the observed variables. So between these independent and dependent variables, there will be some sort of association. There might be association, there might not be any association. And when there is an association, there might be inverted, okay, or not. Okay. So in order for us to present this association visually, we would employ the use of scatter plot, okay, or the scatter diagram. It's a graphical method to display the relationship between two variables. So those variables are represented through the x and y plane. Okay, so proxy x and proxy y. So the y is the dependent, x is the independent. So here we have an example of a scatter diagram. So this is trying to identify the association between a person's BMI and their birth weight. So from here, there are like 15 observations, right? And then through maybe questionnaires or document review, the researcher has plot 15 cases in this scatter plot. And from this observation, we can see that there is a certain pattern emerging from this scatter plot. We can see the association between BMI and birth weight. Dia, how you say, berkadar terus. So if a person has a less weight at the time of his or her birth, so he or she will likely has a you call smaller number of BMI compared to those who are born with higher, bigger weight. So as they develop, they would tend to have a high number of BMI. So this is the association that we can yang kita boleh dapat lah kan daripada from this scatter plot lah. And if you go a little bit further, you can come up with certain formulas, right, from this scatter plot. I'm sure you have learned about graphs when you're back in high school. YMX plus C. So that is something that we can employ here to come up with an equation from this scatter plot. And if we put more variables here, obviously the formula would be a bit longer, and in time, if it can be an equation for a model. So the scatter diagram is first step in determining whether there's a relationship between two variables. Okay, is to examine the graph of the observed or known data. There are two types of information here. It shows the pattern that indicate the variables are related. And if the variables are related, it portrays what kind of line or equation described on the relationship, as I mentioned earlier. So from this scatter plot, we can put a line of best fit, okay, somewhere here, okay, that would describe this association between BMI and birth weight, right? So we can use that as to determine the relationship between these two variables. So if between these two variables there are no association at all, you can see that the plot will be all over the place. Okay, so these 15 dots will be manifested, I mean, all over the graph. So you are not able to, draw up a line to describe the association. So these are an example of proposed steps, okay, to obtain information from the scatter diagram. First, we tabulate the data. Of course, when you have your raw data, you have to do your, the cleaning up of data, and then you try to identify the extreme values, and then decide on what we want to do with the extreme values, and then use the values to tabulate some kind of data, and then transfer the information from the tables into a graph. You plot, and then observe the scatter diagram, and then you draw a line of best fit, and then observe the shape of the line. So it can be linear, meaning the line could be straight or a bit curved. So patterns of relationship here, we have the direct linear, inverse linear, perfect positive, perfect negative. Like if we watch this scatter plot, so this is an example of a linear correlation. So as the birth weight increase, the BMI also increases, right? But it is not a perfect direct linear. So if a perfect direct linear, you start from like zero. Okay, so but it is nonetheless a direct or positive linear relationship. If it's a negative linear relationship, it will cross like this. Okay, so as y increases in value or decreases in value, x will increase in terms of its value. So that is the inverse linear or the negative linear relationship. And then other than that, we have a direct curvilinear, inverse curvilinear, inverse linear with more scattering. This is when we don't really can really identify the relationship, but there are indications that they are. And of course, no relationship at all. So the regression line, okay, we can use the equation, okay, y equals a plus bx. This equation is practically the same from the equation that you learned back in high school or when you learn about graph, okay, y mx plus c. It's just that they changed the order and the representation. So y is the dependent variable. So this is the variable that we want to observe. Equals a is the interception. We're at the part CY itulah. Plus b is the slope of the line and x is the independent variable. So basically y mx plus c. So calculating the regression line, we have the positive slope and the negative slope. So the positive slope, especially for linear relationship, as the value of x increases 1 unit, the value of y would also increase 1 unit. Whereas if it's a negative slope, x increases 1 unit, y will decrease 1 unit. Okay, so the slope is quite important to be observed. And then a and b, okay, so a is the interception, b is the slope. So this is where you have to provide the line of best fit. Okay, so we want the plots to be as close as possible to the line that we have drawn. So this method is known as least square regression. All right, the best estimate using the calculation are given by the following. So this is the equation if you are really interested on it. Okay. Calculating the regression line using regression to forecast. So when A and B have obtained, prediction can be made for values X and Y. So from your observation, once you have, where is it? Yeah. Once you have this line, so this observation is between what, 10 to 60 BMI. So we can extend this observation even more than what is being plotted in this graph. So that is also known as forecasting. Okay? So when you have the values of A and B, prediction can be made for the values of X and Y. So you just elongate that line and then you can have like predictions. Okay. So how do we measure association between those two variables? Yeah, the example has been given there. Oh yeah, so this is referring to the previous scatter plot. So this is the observation. First is the BMI of pregnant mothers, and the second is birth weight of their newborn. So, what is the relationship between BMI of mothers and the birth weight of their babies? So, they want to observe that for some reason. So, their observation is on 15 pregnant mothers. So, this is the observation. So we have BMI, okay, from 10 up to 60, and the birth weight that has been recorded from those to 15 newborns. So what we want to know, is there a linear relationship between BMI and BW, is the birth weight? So is it if the mother has a high BMI, does the baby also have a high birth weight? Okay, so we want to know that. That is something that we put as a research question, but we can also put this as a hypothesis, right? So again, it's all intertwined, related with other topics of research, but we we don't go into the hypothesis for now. So let's stick to the question. Scatter diagrams are important for initial exploration of relationship between two quantitative variables. So we may wish to summarize the relationship by a straight line drawn through the scatter of points. So although we could fit a line by eye using a transparent ruler, this would be subjective approach and therefore unsatisfactory. Yeah, putting the line on best fit on the scatter plot diagram is usually depends on the researcher where he or she wants to put that line within reasonable tolerance. So therefore, a better way of determining the position of straight line is to use the method of least square. So using this method, we choose a line such that the sum of squares of vertical distances of all points from the line is minimized. So this method, least square method, can help us to put the line more objectively, so that people won't be questioning our decision on putting the location of the best fit for that particular line. So I will not go into the detail of this least square method. Um, if you are interested, you can read on about this method. For your level of undergraduate, the method of putting the line in the graph, putting the line of best fit should suffice. Um, so let's see now, least square regression line. So basically, these methods, least square or regression line, it's a way for us to put the line of best fit by using a certain methodology, so that people won't be asking us about our decision on putting those lines. And then we have the linear regression model. And then and application of regression line. All this will help you in preparing an equation for your observation. All right, so and then regression analysis. Experimenting equation is developed. We can equate a mathematical formula. So all those trouble of drawing the best fit of line and preparing the graph and whatnot is for us to prepare an equation, okay, of the related two variables. So the correlation analysis used to describe the degree on which one variable is linearly related to the other. Right. It's all related to the formula. And then the correlation analysis, correlation can also be used by itself to measure the degree of association between two variables. So once we have identified that there is an association, we want to identify the degree of association. Is it significant or not? So to do that, we have two methods of measurement: coefficient of determination, R-square, and correlation coefficient. So R-square, the sum of a group of the squared deviation. So we will not get into this. This is more for like postgraduate students. Okay, so from all those calculations, which actually can do it by using statistical package, SPSS, this is what we want to identify. The RS number, or is it the R square, the R number? So the R number value ranges between +1 and -1. So if the relationship is a +1, meaning that the relationship between those two variables are perfectly positive. Okay, so as X increases one value, Y also increases one value. So that's the +1. So if the -1, the relationship is -1, means that it is perfectly inverse relationship. So as I said, as X increase one value, Y will decrease one value. So that's a perfect negative, and this is a perfect positive. But putting negatives away, we want to know the strength of the correlation. Let's say it is a positive relationship, but we want to know the strength of that positive relationship. So if it's a positive one, down here, it is very strong. So 0.9 to 1, okay, relationship, meaning that there is a very strong relationship between X and Y, right? So anything less than that, okay, it falls under the following category: strong, moderate to low, weak to low, and very low. So even though 0.16 is still positive, the how Y affects X is very minor, okay, compared to zero point 0.9 or 1. Right, so okay, that is it for a bit of introduction, okay, on correlation and regression. It's just trying to find uh, bagaimana one variable mempengaruhi variable yang lain. So kaedah dia kita guna graf lah, kan? Paksi X dan paksi Y. So kalau kita plot kat situ, kita dapat garis yang positif, lurus tu, maksudnya hubung kait dia ialah positif lah. Y naik, X naik. Kalau kita plot, dia terbalik macam tu, it's a negative relationship. So Y naik, X turun. Kan? Tapi berapa banyak dia naik ataupun berapa banyak dia turun, itu that is the strength of the relationship. Tak ada kena-mengena dengan positif ataupun negatif. Kan? So kaedah paling mudah kita menggunakan kertas graf lah, kan? Kita graf, kita plot and then kita lukiskan garisan. Itu kalau kita buat kaedah manual lah, kan. Kalau kita buat guna SPSS, most likely the software will draw the line for you. Okay, you can just pick it up from there, right? So kat situ pun ada kaedah-kaedah yang kita boleh gunakan untuk menentukan garis berkenaan menggunakan kaedah tu, so that people tak boleh nak argue lah, kan. Kita menggunakan proper method, kan. So itu baru nak cari association antara dua variable X dan Y. Belum 3, belum 4, belum 5. So kalau tambah lagi 3, 4, 5, itu yang kalau tengok formula tu berderet panjang, kan. Y equals ni plus ni minus ni plus ni, kan. Sebab ada banyak variable kat situ. Yang kat sini kita baru satu, kan. Satu, bagaimana satu variable mempengaruhi satu lagi variable, kan. So it's a bit of an introduction on this topic. I suggest that you surf the internet or to get more exposure on this topic, okay. Correlation and regression, right? So this is something unique when you are doing bivariate analysis. Ada relationship kat situ. So kalau you buat just univariate, just descriptive saja, dia takkan ada benda ni. Okay? Dan yang paling best tu kalau kita dah buat garis ni, ada garis tu, kita boleh panjangkan garis tu untuk buat future predictions. Okay? Buat ramalan. That is something that you cannot get from descriptive. Yeah? Baik.